All right. Well, yeah, I kind of want to just check in, see how you guys are doing. It's been just, you know, Monday we had lecture, and I was all excited to be back on campus and whatnot. And then, yeah, a bunch of crazy stuff happened. Campus received threats of violence, and then I heard reports of a student dying in the residence halls, and these things they weigh heavy on the heart of the campus. They weigh heavy on my heart, and I'm sure for a lot of you as well. And I think whenever we're faced with some tragic events and some scary events, it's a normal process, part of the normal process to I guess just be confused about what's happening, and also to kind of just wonder. It's also okay if you just kind of have these thoughts of like, man, what am I doing, right? Like, why am I coming to college or things like that, right? That all of these things, they're part of the normal process, and also if it hasn't affected you, also that's also, I want to give you room to not feel things as heavily either, right? Everybody kind of responds differently, and don't feel like, oh, you have to feel bad because other people are feeling bad and things like that, right? We all kind of process these events and things differently, and that's fine. If you are struggling, I want to encourage you to talk to somebody, either a friend, a family member, or a professional. I don't want anybody to feel like they have to face these things alone. And at the same time, if you do, on the other hand, if you feel like you have the emotional capacity to be a support or a friend to someone in need, I want to encourage you to do that. It does require sacrifice on your part, in that it takes energy to listen to somebody, and sharing someone's burdens means you have to kind of feel the weight of that burden too. But if you have the capacity for it, I want to encourage that. We all need each other, and there will be times where you're able to be there to support someone, and there will be times where you need to turn to someone else to support as well. So that's that. There is a balance between being too emotionally available and taking on everybody's burdens, and then that brings you down yourself, and that's kind of a balance that you have to figure out yourself, and have appropriate boundaries for whatnot. But yeah, we need each other. We need to support each other to through difficult circumstances. I don't know if it's of any help, but as far as the homework, I think homework 3 is originally due today, right? It's due today. Okay, the deadline is still due today, but if you want an extension, everybody can have a 3-day extension. I won't ask for documentation. Just, I get it. Okay. So if you need an extra 3 days for this homework, that's fine. Just submit it within 3 days, and we won't assess any kind of penalty. If you need more than 3 days, come talk to me, and we can do that too. Yeah. So otherwise, if you can turn it in today, turn it in today, and then it's no longer weighing on your mind anymore. But if you're just not in the space to kind of work through your homework, and you could use a couple extra days, you have that as well. Okay. I don't know if you guys had any thoughts or wanted to share anything, but yeah, I hope you guys are doing well. All right, let me go ahead and, if it's okay, we'll transition in an awkward way and start talking about the R6 object-oriented system. And so on Monday, we left off, I had introduced the S3 object-oriented system, and we said S3 uses a generic function approach. And R6, I mentioned it, and I said R6 uses an encapsulated object-oriented programming paradigm, okay? So again, the generic function the methods belong to the functions. So you have a function like run, and depending on what object you're given it, when somebody says run, you're going to do something different, right? So if I give you an engine, running it would be like having the engine turn. If I give you shoes and I say run, you're going to put them on and start going for a jog and things like that. So the methods belong to the functions, and the function is going to look at the object received and figure out what is the appropriate thing to do, what is the appropriate function or version of that function to run. In an encapsulated OOP system, the methods belong to the objects themselves. Okay, so within the object, there's just a list of kind of things that you can do inside the object. Okay, and so the methods belong to the objects, and you call them by doing object $method. So if I give you shoes, there might be a method that's like tie laces or something, right? Or if I give you a coffee machine, there might be a method, brew coffee, brew strong coffee or brew weak coffee or something like that, or keep the plate hot. Okay. One thing that is interesting compared to the rest of R is that R6 objects are mutable. Okay, almost everything else in R are kind of immutable, and if you want to modify it, it runs a copy on modify system. And you probably don't even think about it, but basically, if you wanted to change the values within an object, you have to assign something to that object in order to kind of change the values without, and you generally values don't change when you run a function, right? So if you think about some vector x and you call sort x, sort x returns the vector sorted, but the original value x remains in its original form, right? X is not affected when you call sort x. Sort x gives you back kind of a new copy where it has been sorted, but the original vector x remains in its original order. Okay, and that's kind of the normal way we interact with objects in R. When you have an R6 system, you could have an object, like a vector type looking object, where maybe you have a method called sort. And if you call x $sort, what it will do is it will modify that object x, and x will now become a sorted version of itself. All right, if that kind of makes sense. So that's kind of what we're going to do. So R6 is not part of base R. You have to call in library R6. There is reference class objects, which is part of base R, but R6 is more elegant, and this would be the recommended method for using reference class objects. Okay, and whenever you want to create a new class of object in R6, you use the function R6 class. R6 class. That's pretty much the only function in R, in the R6 package, that you will need. And everything else is kind of created when you run this R6 class thing. The function, when you run R6 class, basically needs two things at least. One is the name of the class that you are creating. By convention, we have class names are upper camel case, meaning we don't use underscores. If we have multiple names, multiple words in the name, you just kind of capitalize each new word. Okay, upper camel case. And upper camel case means the first letter is uppercase. There's also something called lower camel case where the first letter is lowercase, but here upper camel case is what we have. And then you have, so that's the first thing, just the name of the class we're creating, upper camel case. And then the other argument we need is a list called public. Public is a list of methods and fields. And the methods and fields use snake case, which this is convention. It's not like a law. It's not going to throw an error if you don't follow this, but this is the convention. And so you use underscores between words. Okay. You should always assign the result of R6 class into a variable with the same name as the class. And this will be an R6 object that defines the class. So for example, we can create this R6 class called accumulator, capital A accumulator. The class name is accumulator, and the public will be list, okay? A list, and there are two fields. One field, which is sum, and one method, add. So list contains two objects in it. One is the sum, which is just a number 0, and the other is add, which is a function, okay? And the function is takes in a default value of x equal to 1, and we'll get into what this function does, okay? But this basically creates a simple class called accumulator, one public field, which is sum, and one public method called add. And when you come back, so after we've assigned this to accumulator, if you come and say, okay, what is accumulator? It's going to print out all of this stuff. It says accumulator is an object generator. Yeah, question?
So for R6, at least in R, is it closer to a class in C++?
Yes.
Okay.
Yeah.
I also see that, for example, the add function, we use like self.
We'll get into it.
Okay.
It's have you used classes in Python?
Yeah, I have.
Okay.
Which is why I recognize.
Yeah, classes in Python also use kind of references to self and things like that. And it's gonna be, we'll talk about this, okay? So this uses kind of reference message passing object-oriented systems, which again, very different from generic function OOP. So yeah, if you've seen OOP before, it's probably been something that looks like R6, just of course in a different language, but there's some kind of similar paradigm. The generic function thing, R is not the only language that has generic functions, but it's much less common as far as OOP systems go. Okay, so anyway, you come back and it kind of gives you this information. It lists off what's inside public. Public has sum and add, and then you also get this clone function, which is kind of, it inherits that, and then it tells you the parent environment and all sorts of other stuff, okay? But it just gives you some information. And so what you can do is you can kind of, if you wanted to create a new instance of this accumulator class object, you call accumulator $new, okay? Now, we never defined the function new, but anytime you call an R6, this original thing where we called R6 class here, that's going to automatically create some of these necessary methods, okay? One of them being new, one of them being clone. And so we can create a new instance of the accumulator class object, okay? So, and an instance is basically like, oh, this is one instance of that, right? It's just kind of like, you know, we could have a bank account, and each of you can have a different and separate bank account, right? And these are all different instances of a bank account entity or object, okay? So here we have X. X is an accumulator class object, and we can say, well, what is X? And X is an accumulator. So notice this is different. Over here, this is the object generator. Once we've created a new object of that, it's not an object generator. This is an accumulator class object. It comes with the public fields, which has the public field 0, sum, and it has the method, public method add, okay, along with public method clone. And we can just say, hey, what is the value of the sum field in X? And we get X $sum, and it comes back and says the value there is 0, okay? And we can call X $add, all right? And what add will do is it adds 1 to the sum. So here we start off with what is sum? Sum is 0. I call X $add, and this modifies the value stored inside X, okay? And now X $sum is now 1, okay? Normally, to change a value in R, you have to do X $sum is equal to, or assign X $sum plus 1 or something like that. But we didn't have to do any kind of like assign business to this thing. We just called the method add, right? And now I can say add 3 to it, and again, now it has modified it to 4. So what is happening when we do this, right? So inside, okay, we'll shrink that. Okay, so the method $add. Uh-oh, did I break this? I hope it's recording. All right. Okay, so what we're doing is we're taking the value self $sum. Okay, we're taking the value, the field sum, and we reference the value inside the object by calling self, okay, or by using the name self. So it says within this object itself, what is the field sum? Okay, the field sum is currently, whatever, 0. It starts off at 0. And then we're going to take sum, add x to it, and store it back into self $sum. Okay, and so this is how we're updating it. So the thing that we normally have to do in R, where we assign things back to its object to kind of update its value, happens inside this method here. So inside this method here, we're going to take the sum thing, add x to it, and update the sum value. Okay, and then what we do is then we return the object self itself. Okay, invisible is basically another equivalent of return, except invisible just means return it, but don't print it out. Okay, return it invisibly. Okay, and because the object itself is returned, we can chain the methods. Okay, so here, what is the sum value? I can do sum 4. Okay, now if I do x $add, this is going to be an accumulator object where the value is now 14. Okay, and because this is an accumulator object, I can call $add 10 again, and so now this whole entire thing is an accumulator object where the value is 24 inside sum. And then, and then I can ask, well, what is the sum value, right? So we can kind of chain these methods together by calling $add 10, $add 10, $sum, and we get back the field sum, which is stored inside this object, and that field now contains the value 24. If you have seen Python, if you've used Python, you might be familiar with method chaining by using a whole bunch of dots, right? So you can kind of have like series dot values dot, whatever this and that, data frame dot column name dot something, okay? It's kind of like that, except we're using $signs in R6, okay? So we called add method, and that, because it returns itself invisibly, we can also call the add method again, and we can also call the sum, ask for the sum field. Does this make sense as far as what's happening? Chaining these methods together. Oh, okay, before I forget, your view quiz answer, today is week 5, Wednesday. I have to look this up. Today's first view quiz answer. First view quiz answer is B. B as in bear. B as in bear is your first view quiz answer for today. B. Okay. We often recommend, as far as reading, okay, we would recommend for readability, putting each method kind of on its own line, okay? Because generally, when you write code, you want each line to be one simple change, okay? That there's kind of an expectation that each line does kind of like one action. And so if you're going to do like multiple things all at once, split it up across several lines, all right? Sometimes that means your code ends up being a lot longer, but the goal generally is readability, all right? Okay, the computer doesn't care if it's a bunch of lines or one line, okay? It's gonna read it, it's fine, okay? Who cares? You, the programmer, someone else, a human, and we want it to be nice and readable, okay? Obviously, if you can do your thing in a few simple functions, few simple lines, then do that. But there's no prize for having writing unreadable code that only takes up one line. Okay. All right, initialize. There is, everything is $, to create a new instance of an R6 class object, we use $new. But $initialize, what that will do is it will kind of override kind of the default behavior, right? And so it allows you to kind of define required fields and stuff when creating a new object, and performs checks to make sure that those values, those inputs, are valid, okay? So here I'm copying an example straight from Hadley Wickham's textbook, and we're going to create a new class called person. The person has two fields, a name and an age, okay? And basically, so we got two fields, name and age. Name is null, age is NA. And initialize, to kind of, this means when you create a new person, you have to provide it a name and you have to provide it an age. And what we will do is, within this code, when we call $new and create a new instance of a person, we're going to check to make sure that the name is a vector of length 1 and it's a character vector, okay? And if it's not, we're going to stop. We're going to throw an error, okay? We're going to check to see if age is numeric, and age is a vector of length 1, and if it's not, we're going to throw an error, okay? But if it passes these things, then we will take the name that came in the function and assign it to $name. We'll take the age that came into the function and assign it to $age. Yeah, question? Oh, so this is a list. When you kind of have names in a list, you use the equal sign. Yeah, I don't know. This is just kind of the convention that we have within the R6 class. Will it throw an error if I use an arrow here? I'm not sure. I've always seen it with an equal. I haven't tried it out. I haven't tried it out with the arrow, so I don't know. Yeah, question?
So on the public section of the list, we first declare name equals to null and then age equals to NA.
Yeah.
But then why do we declare again age equals to NA initially but not name?
I mean, I guess that was unnecessary. Yeah. Okay, so let's try this out, right? I want to create a new instance of person. Now notice I call $new, not $initialize. Okay? The initialize method changes how $new behaves. Okay? $new generally just creates a new instance of this thing. Okay? Here we're going to say we want to create $new, and what is it going to do? That's going to be a function that requires two arguments, name and age. So we say Hadley, age 38. Okay, and it comes back and it says that doesn't work because this thing 38 is not numeric. Okay, is not true. So it errors out. Okay, but here I can do Hadley age equals 38, and this creates a person, and our object works there. Okay, and then so now we can say, all right, if I print out Hadley, we get basically the default printing, and it lists off the public fields, age 38, name Hadley, along with the other public methods that exist, the clone and the initialize. Okay. Now what we can do is we can define a print method. A print method will activate anytime we ask for the object to be printed out. Okay. So our R6 class definition gets more complicated because now I have an initialize function, and now I also have to have a print method. Okay, so this print method is going to cat multiple things to the screen and return itself invisibly. So we're going to get cat person, new line, indent 2 spaces, name colon, the name, age colon, the age, along with new line characters, return itself invisibly. So we'll do this. And so because I've redefined this thing, I'm going to create a new instance of this person class. We're going to call this person Hadley2. And again, Hadley 38. And now when I ask for Hadley, when it prints out using the print method that I defined here, okay? Versus the default print method, which looks like this. Okay, so this now only has the values that we've put in there. Okay. All right. So remember when we created this person Hadley2, which is a person class object, that had the print method defined. When we had first created a Hadley, the class definition did not include the print method. Okay. And so just because we changed the definition of the person class object isn't going to like retroactively update all of the instances that we've created in the past, right? So it's kind of like, you bought a Honda Civic in 2015, okay, and they come out with a new version each year. So someone else gets the new 2020 Honda Civic. Just because they updated the model in 2020 or 2022 or whatever is not going to retroactively suddenly make your old version up to date, okay? You'd have to buy a new car if you want the latest version, okay? So the old Hadley, which was defined under the old person definition, still doesn't have its own print method, okay? There's no relationship between these two objects, Hadley and Hadley2. They are two separate objects that just happen to have the same class name, which is capital P person, okay? Anytime you're working in R to develop a class definition, having multiple objects that share the same class name but have different class definitions can become confusing. So whenever you update a class definition, the recommendation is to delete everything with the old class definition, okay? Otherwise, and then to redefine them with the new class definition. Otherwise, you're going to get confused. Okay, you can modify the fields and methods of an existing class. So if you have an existing class, you can do $set, okay? And so, earlier we had, so here we're going to create a new instance of the R6 class, or not a new instance, a new definition of the R6 class accumulator. And I said you had to kind of provide a public list of public fields. And right now, we actually didn't provide it, but it'll create this. There's just nothing in public. But here we can set public fields, okay? And so here we're going to do $set, and we're going to create a field called sum with default value 0, or not default value 0, sum with value 0, and that's going to be in the public field. And within public, we're going to create a method called add with this function definition. Okay, and again, these new methods and fields are only available to new instances of the object. They're not going to go retroactively to the old things. All right, just like other objects, we can have inheritance as well. Okay, so we're going to create something called the chatty accumulator. This is kind of like the verbose version of the accumulator. Okay, but before I go on, you have a question?
Yeah, really quick on the adding methods application. It's really simple. If we do, it's like we do it after we define the class. But if we were to do this like during the class creation, it would have achieved the same thing.
Yes.
Okay.
Yeah.
Thank you.
All right. So here we're going to define a kind of a verbose, a chatty version of the accumulator. Okay, and basically we are going to inherit everything from the original accumulator. Okay, so we're going to do R6 class accumulator chatty. We're going to inherit from the top level accumulator. The top level accumulator has a sum field and a public an add method in the public list of fields. And so the only thing we're going to do here is we're going to change the definition of the add method. The add method is going to cat, and it says it's going to print out adding X onto the screen. Okay, so it's going to print something onto the screen. Okay, by catting a line there. Okay, and notice this part. Okay. Rather than doing self $X or self $sum is self $sum plus X, what do? We called super $add. Okay, and so what this says is, you are inheriting all of the methods and fields from the parent class, which, granted, it's a simple parent class, the sum and add function, and we're defining kind of a new version of this add function. And here it says use the parent class method, which was add. Okay? Use the parent class method add, where you're going to add X, and that's going to do the sum. Self $sum is self $sum plus X. Okay, and so here I'm going to create X2, which is an instance of this accumulator chatty. And we're going to do X2 $add 10, $add 1, $sum, and now whenever I call these methods, we're going to add it now cats these values, adding 10, adding 1. Okay, and we can do this because, again, the parent method add returns itself invisibly, and so I can do method chaining. All right. Does this make sense? What's happening here? This use of super and accessing the fields and methods available in the parent method. Okay, and I think I've listed all of this out in the closer look here, where I talk about the call to super $add calls the original add method in the original accumulator class. Okay, when you call a class on an R6 object, it will give you a vector of all of the classes that it belongs to. So Hadley is class person, okay, which is R6, which also inherits from R6, and the top level R6 has methods like the clone and the new and things like that. Okay, Hadley 2 is also defined under person class, but these are different definitions of what a person is, right? Okay, accumulator X2 is accumulator chatty, which inherits from accumulator, which itself is an R6 object. Okay, you can ask what are the methods and fields available within some kind of within an object. So I could say, what are the names inside Hadley? And it comes back and says you've got the age, the name, clone, and initialize. Hadley 2 also has age, name, clone, and print, and initialize here. Okay, so these are all kind of new, the names that have that, right? Okay, let's take a look at reference semantics here. Did I already give you your second view quiz answer? Not yet. Okay, let me go ahead and give you your second view quiz answer. Second view quiz answer is D as in dog. D as in dog. All right, so most of R uses copy on modify. So here if I do A is 1, 2, and then we assign B and A, currently right now at this point in time, both B and A point to the same object in memory. Okay, so we've created an object in memory which is a vector containing the values 1 and 2, and A points to that object, and when I say assign B to A or A to B, B also gets a reference to that same object. But now I'm going to say take B1 and add 10 to B1. So basically 1, add 10 to it, we're going to get 11. And when we do this, R says, oh, you're changing this, and so it creates a copy. So A still points to 1, 2, and it creates a copy, which is now going to be 1, 2. It adds 10 to it, and it gets 11, 2. Okay? And so these two things have different values. We got 1, 2, and we have 11, 2. So these are, R does copy on modify. When you modify something, it creates a copy of that object in memory, and it changes the value. Look at what happens here. I'm going to create a new instance of the accumulator object. We're going to call this thing X. So X is going to be an object in memory of class accumulator. Inside this object, and then we're going to take Y. Y points to the same object X. Okay, these two names, these are two names for the same thing here. Okay, and now I call add 10 to Y. When I call add 10 to Y, okay, we start off at 0, and that sum value now becomes 10. Okay, now with reference semantics, R is not going to do copy on modify. It's going to modify the object itself. So this object in memory, which has the names X and Y pointing to it, now has a sum of 10. So when I ask what is the sum in X, it's the value 10. What is the sum in Y? It's the value 10, because they're both pointing to the same exact thing. It's just two names for the same thing, right? Some people call you, there might be a person named Thomas, and we can say, what is Tom's age? Somebody else, or what's Thomas's age? Someone else can call the same person, Tom, or Mr. Jefferson, or whatever, okay? And we're all talking about the same person, okay? It's just multiple names for the same thing. And that's all this is, okay? We're talking about the same thing. Okay? If you don't want that, if you want a copy, you have to use the clone method, okay? So here, X is a new object. I can create a clone of X and call this Y, okay? So I create an object in memory called X. I create a clone of it, and now I have X and Y. I can add 10 to Y, and this value now has the sum of 10. This value, the original, has a sum of 0. So if I ask X sum, it's still 0. Y sum is now 10. Right, so these are different. These are now talking about different objects, and when you modify one, it doesn't modify the other. Okay. All right. Reference semantics can be tricky. Should be handled with care. So look at this simple object, or simple example with base objects. Okay, so I've got X. X is a list with name A equal 1. Y is a list with name B equal to 2. And Z is going to be a function, or Z is going to be the result of applying a function X, a function to X and Y, right? So we have some function F which takes in arguments X and Y, and it returns something Z, okay? And when we do this, so using base R, the only thing that's going to get modified is going to be the object Z. Okay, when we call this function X and call this function Y, we know that X is not going to be changed by this function call. We know Y is not going to be changed by this function call. Okay, what if we did this? So now we have some R6, imaginary R6 class list. Okay, Y is also an instance of this R6 class list. Okay, here this function F takes X and Y as inputs and assigns a value to Z. Okay, and now we are not sure what's going to happen. Okay, because R6 uses reference semantics within this function, there could be calls to methods within X and methods within Y. And this function could end up modifying values inside X and values inside Y. We don't know unless we know the definition of what's happening inside of F. Okay? And so this function call could modify X, it could modify Y. It's certainly going to modify Z, but we don't know if it has also modified X or Y unless we know what exactly is written inside the function F. Okay? And so certainly when you run into unexpected behaviors and you go, hey, where did X get modified? Okay, as you're reading your code, you're gonna read this and you go, oh, did X get modified here? Or did it get modified in this other line? Did it get modified? And it gets a lot harder to troubleshoot because this will now require you to know exactly what is the code that's happening in F? What's the code happening in this other function G? What's the code happening in this other function J? Okay, you have to know what's happening inside of each of those code. Because any of those things could be modifying X, and you don't have an explicit indicator on the outside that says this is where the modification is happening. Okay, so one recommendation is that when you interact with an R6 object, okay, and again, this is not a hard rule that says this is it's not going to throw an error if you don't follow these rules. But for your own sake, so you can debug your stuff easier, okay, when you write a function, it should do only one of these two things, okay? Return a value. If it's going to return a value where you're going to assign it somewhere, it should not modify the inputs, okay? Or if you're going to modify the input, it should not return a value, okay? And if you kind of follow these two principles, as you're reading your code, you can you'll have an easier time understanding, because you'll see a function call where it's not being assigned anywhere, and you can say, okay, this function call is modifying this object, okay? Or you see a function call where it is returning something and the value of that function is being assigned somewhere, you can say, okay, this is only modifying the thing that's being assigned. So if you follow these two things, it'll make your code easier to understand. But again, these are not implemented. They're not going to throw errors if you don't follow these things. It'll just make your life harder, okay? So either return a value, don't modify anything in the objects, or modify the objects and don't return a value. So, here's an example where we want to create a function. A function is going to add 5 to the sum, okay? So this is going to take an accumulated class object, and it's going to add 5 to it. Now this thing will make a call to add x, okay? Or make a call to the accumulator class. It's going to add 5 to it, and it doesn't return an object, okay? It just modifies x in place. So I can do add 5 to some x. We know we don't see it, the result of this thing being sent anywhere, so we can say, okay, this kind of function call is going to modify x in place. All right? There's no assignment operator. We go x $sign sum. Indeed, it is now 5. Okay? Here's a different function. We call it sum times 10. This thing takes the field accumulator $sign sum, multiply it by 10. Okay? And so when we call this thing, we assign it. We're going to say sum times 10. And this is going to get assigned to y, which will be 50. But so it's returning this value, whereas because it's not modifying anything inside x itself remains 5 here. Sorry for the text overlap. X itself remains unmodified. So by when you see your code, written this way, that should help. Okay, you see the assignment operators. You say, okay, I don't have to worry about modifying x here. We know y is being changed here. Okay. When you don't see an assignment operator, you can say, okay, this function is modifying x. Okay, there's a few different fields within. We've talked about public fields, but I also want to mention private and active fields. Okay, and I'm going to just say this stuff. Talking about private and active fields, I will not put it on the midterm exam. Okay, and so the midterm exam is still planned for 1 week from today, and I'll cover what I want to go over on the midterm on Friday. Okay, I'll give you a little bit more description there. But I'll just go ahead and say this stuff on private and active fields will not be on the midterm exam. And I'm going to post a homework assignment using R6 classes later today. Okay, and it's not necessary. This stuff on private and active fields is not necessary for the homework assignments. You can just do everything at public fields. But you can kind of learn more, and I just kind of wanted to see this because it's some cool stuff that you can do. Before I go on, let me go ahead and give you your last view quiz answer for today. Today's last view quiz answer is the letter A. A as an apple. A as an apple is your last view quiz answer. So when we define an R6 class, we provide a list of fields and methods, and we call that thing public. Okay. You can also create a list of fields and methods called private. Private means these objects and methods are only available from within the object, and they cannot be accessed from outside. Okay? Private does not mean secret. So it's not like it's encrypted or anything like that. Okay? You can still kind of get at the values in a private object. It's just they can't be accessed or modified directly from the outside. It's not like a place to store secrets or something. Okay, so here with a public field, here's just a very simple class definition. Inside public, we've got name, we've got age. When we created the age, we started off with 38. You could just directly modify the age. You can call Hadley to $age, say I'm going to assign 25 to it, and that's going to change the age. All right? So public fields can be accessed directly from the outside. It can be modified directly from the outside. What we can do is we can take the name, age, and name, and we can put them inside private. Okay? Inside private. And what this means is we can't access age and name directly from the outside. We'll just have a very simple name and age initialize function. We're not going to bother checking for validity. We'll just take the name and age provided in the initialize, assign it to private $name and private $age. Okay? And then, and so we're going to access these things using private $sign rather than self $sign. And then when we call print, because print is inside the function definition, we can access these values using private $name and private $age. Okay, so when I do this, we can create a new person called Hadley, person 3, Hadley with age 38. If you ask what is Hadley 3 $age, it comes back null. Okay, this is not a value accessible from the outside. If you try to assign something, and you do 25, assign it to Hadley 3 $age, you get back an error. Okay, you can't modify this stuff. But the values do exist, and they show up when you do Hadley 3. Or you just ask for it to print. When you print it, it prints out private name and private age. Okay, so we can get the values because they are stored inside the thing, but they can only be accessed through kind of the methods. It's kind of this controlled access to these values rather than allowing anything to just kind of access and modify them. Okay, and the last thing, and I'm going to run out of time, and I'll just encourage you to look over these slides on your own bit, are these things called active fields. Okay? Active fields allow you to define something that looks like a public field, meaning that you can access it. Okay, and maybe even modify things and stuff, but the value that shows up when you call an active field is actually defined by a function. Okay, and so an active field is created by defining a function that takes a single argument, and if the argument is missing, okay, then it's going to retrieve the value. And if an argument is provided, this value is provided, then it's going to modify the value. So it sounds a little confusing, but we're going to create, this is a random value. We're going to call random, and we got one active field called random. Okay, and basically, if a value is being, if it's missing, it's going to return a random value, and if it's not missing, it'll throw an error. Okay, so here we're going to say, give me a new value, and we call x $random, and it acts like a public field. Okay, but the result of this is the result of a function we're calling RUnit, and so every time I call x $random, it's producing a different value here. Okay, so even though we're accessing it as if we're accessing a public field, but it's actually the result of some kind of function. Okay. Now, in practice, we can use active fields in conjunction with private fields. Okay. All right. I'm way over time. We'll just call it an end here. You can look over these slides. I think the examples are pretty interesting. Okay. Where we store the values age and name in a private field. Okay. But within the active field will retrieve the private age, and if someone tries to assign something to age, we're going to come back and say age is read-only, okay? And you can look at the definition of name, all right? So this allows us to kind of access the age using like it's a public field, right? Because when it was a private field, you couldn't even do this. You couldn't do $age, it gave back null. But now we can access it as if it were like a public field, but we can also control it so people can't just modify the age. Okay, where the public field, you can access it and modify it. This is, we can kind of control it where you can say you can access it like a public field, but you're not allowed to modify it and things like that. Okay, anyway, look over the rest of the slides for more details. We'll end here. I'm happy to see you guys. Have a good rest of your day, and we'll see you guys on Friday.